This is Physics 2211, Lab 5, Air Track Collision. An introduction. The purpose of this lab is to analyze the motion of a cart colliding with an identical cart on an air track using the tracker app. We want to plot the displacement of the cart against time to find relationships between the mass, initial velocities, and final velocities of the cart. The system includes both carts, the air track, and the Earth. Surroundings include everything else. And here is our preview of our results. So, the principles. First of all, the conservation of momentum. In a collision occurring in a closed system, momentum, as defined by this formula here, is conserved if there are no external forces, meaning if F net is 0, change in momentum is 0. And from that, and the formula of what momentum is, we can derive this equation. Note here that M1 is equal to M2, since they are identical carts. Also note that M1 is labeled as the cart that I tracked in the video and took the data points from. M2 is the one I did not track and have unknown variables for, as you'll see later. So here's my tracker video. On the right is the cart that I tracked and the data that I got from it. So an analysis. Well, we need to find the initial and the final velocities of the cart that I tracked, meaning V1. So we can do that using the definition of what velocity is. We know that it's just the change of displacement over the change in time. So doing that and taking the first two, meaning here, and the last two, meaning here, data points, we can find both the initial and the final velocity. Note that they have different signs. This is because when the cart collided, it changed directions. We can continue our analysis by using the previously stated fact that the masses will be the same to cancel out the masses and get this. Note that V1 for the initial and the final is the cart that I tracked. So, plugging the values from the slide before, we can get this. If I wanted to find the final and the initial velocities of the cart I did not track, I would either have to A, track the cart, or B, some other way, find out the velocity either initially or finally to find one or the other. So what does it mean? Well, since we assume the system to be a closed system and no external forces to be acting on it, the final and initial momentum of the system must be equal to each other. We also found that the range of values for the velocity of the other cart at the beginning and at the end were modeled using the equation shown. Well, also the velocity of the other cart must be opposite in sign of the velocity of our cart at all times, except at the moment of collision, when velocity is 0 for both. Note that this is a very, very small time period, which we usually do not take into account. Velocity of cart pre-collision does not change during the pre-collision motion, and velocity of the cart post-collision also does not change during post-collision motion. So let's talk about errors. Well, going on what I just said about it not changing. However, the graph of displacement against time is uneven, suggesting that the velocity does in fact change. So why is this error? Well, it suggests that there's human error when selecting the center of mass in the tracker app. Additionally, this may have been due to the axis the carts move along not being perfectly straight, or the camera in the video not being perpendicular to the motion of the cart. The calculation of initial and final velocities would have been much more accurate if taken over a larger time to reduce error and make a more reliable calculation, as opposed to what I did when I took the first two data points and the final two data points. Most importantly, it's really not a closed system because there's external forces such as friction, air resistance, perhaps even someone blowing or the AC still acting on the system. So for my what if question. What if the collision was inelastic, i.e. the carts stuck together? Well, the conservation of momentum principle would still apply. However, the final mass would have been the mass of the two carts added together, 2m, since they are traveling as essentially one object, and we can model them as essentially traveling as one object. Also note, another thing that might be different is the kinetic energy may be lost in this inelastic collision. While it is certainly preserved in elastic collisions like the one I've modeled in the video shown to you.